This question comes from A2 paper 3 June 07. One design of a particle is the synchrotron. A development of the cyclotron. State two features of the synchrotron that distinguish it from the cyclotron. So the cyclotron, remember, had particles which accelerate in an increase in radius. The synchrotron keeps that radius constant. In the synchrotron as well, the synchrotron as well, the B field has to be changed in order to keep the particle going around in that single circle. Therefore, that's different from the cyclotron, which has a constant B field. So the synchrotron the particles travel in a constant radius. Okay, the cyclotron increases. The B field and the synchrotron increases in order to keep it in that constant radius, whereas in the cyclotron it is constant. Next part of the question then asks us to show that in a synchrotron the path followed by a particle of mass m and charge q at a speed v has a radius of curvature r given by, and that's the equation. So we want to show that that's the case because it's going in a radius of curvature r, it's going in a circle with radius r. We can therefore say that F, the force, is equal to mv squared over r. But because it's going in a circle caused by a magnetic field, then B field causes a force equal to B times Q times V. So what that means then is that BQV equals mv squared over r. Therefore the V cancels across there and we're left with, if I bring the r up here, r then is equal to m times v and divide across by b times q, and that's what we were to show. QED. The Large Electron Positron Collider, known as the LEP, which is in CERN, accelerates electrons and positrons to kinetic energies of 50 gig and has a radius of 4.25 kilometers. The superproton synchrotron at CERN accelerates protons and antiprotons to kinetic energies of 450 in a 1.1 K radius circle. Both the LEP and SP involve particles and their corresponding antiparticles. What is an antiparticle? Okay, so what do we mean by an antiparticle? Well, an antiparticle is basically, it's a particle which has the same mass but an opposite charge. So with the same mass but opposite charge. Now there are other properties which will be different as well, but it's essentially the charge which we use at A level to distinguish the antiparticle. So a particle with the same mass but opposite charge, or an identical particle with the opposite charge. Next part of the question then is what happens when an electron collides with a positron in the LEP, the Large Electron. Can't remember what P stands for, but anyway. Well, whenever an electron collides with a positron, so it's meeting its antiparticle, so whenever those two meet, they annihilate, and the term is annihilate, okay, so they're not destroyed, they're not wiped out, they annihilate, and as they annihilate they produce 2 or more gamma photons. So when the electron and proton, and positron collide, they annihilate, and form gamma photons. Assuming that we have the same B field on both machines using equation 3.1, okay, so if we remember again, equation 3.1 was this equation here, R is equal to mv over bq, so we're using R equals mv over bq, and what we know is that if you look at the details that we had for the LEP compared to the SPS, what we know then is that the LEP has a much larger radius, and so if B is constant and the radius is getting much bigger, then V must also, and so V must be larger than in the SPS. Okay, that's the end of that question.